parallel to applied magnetic field the material becomes magnet. So its magnetic moment per unit volume is called magnetization. So when we place a material, given material inside a magnetic field, the current loops are aligned along the magnetic field. So material becomes magnet, and its magnetic moment per unit volume is called magnetization I. So I is directly proportional to H. More is the magnetic intensity, more will be the magnetization. The unit of I is also as that of magnetic intensity, so it is also ampere per meter. So this is the definition of magnetization. The next topic is the magnetic permeability. For a material, we have various types of materials, magnetic materials, like paramagnetic, ferromagnetic and diamagnetic materials. So we define a term magnetic permeability, which is denoted by mu. So this is defined as the degree to which applied magnetic field can pass or permeate through a material is called magnetic permeability. Its value is different for the different materials. Another definition is the number of lines of magnetic field flux density passing through a material. Is called magnetic permeability. Magnetic permeability for free space or vacuum is denoted by mu naught. Next is the relative permeability. It is denoted as mu r. This is a ratio of mu upon mu naught, and it is defined as the ratio of number of lines of magnetic field density of the medium to the number of lines of magnetic field density in vacuum is called magnetic permeability. So this is the definition of relative permeability. Next is the units of mu, mu naught and mu r. Now all these are unitless quantities. Mu and mu naught are the unitless quantity. Since mu r is the ratio of mu upon mu naught, this is also unitless. So next topic is magnetic susceptibility. This is another property of magnetic materials. Magnetic susceptibility symbol is xim. This is also a Greek symbol. So this is defined as the ratio of magnetization I to the magnetic intensity H is called magnetic susceptibility. Since we know that the magnetization, degree of magnetization depends upon the amount of magnetic intensity. More is the value of magnetic intensity, more will be the magnetization. So removing this symbol of proportionality, we have a constant which is called magnetic susceptibility xim. So this is equal to I upon H. This is the ratio of I and H. This is also a unitless quantity. Now the value of this magnetic susceptibility xim is 0 for vacuum. In case of vacuum, the I is 0. Magnetization, there is no magnetization of the for the vacuum, so value of xim is 0. For diamagnetic materials, the value of xim is negative. It is always less than 1, less than 0 for diamagnetic materials. For paramagnetic materials, the value of magnetic susceptibility is positive, which is it is greater than 0. And for ferromagnetic materials, the value of xim is little larger and positive, which is greater than 0. Also, we have a relation between various terms. B is equal to H plus 4 pi into I. If we divide both sides by H, we have B upon H is equal to 1 plus 4 pi I upon H. B upon H is equal to mu, magnetic permeability. This comes out to be equal to 1 plus 4 pi into xim. So this is the relation between magnetic permeability and magnetic susceptibility. Now, as the value of xim is less than 0 for diamagnetic materials, so mu is less than 1 for diamagnetic materials. Since xim is greater than 0 for paramagnetic materials, so mu is greater than 1 for the paramagnetic materials, and xim is greater than 0 for ferromagnetic materials. That's why the value of mu is also greater than 1 for ferromagnetic materials. Depending upon the magnetic properties, there are 3 types of materials: diamagnetic, paramagnetic and ferromagnetic materials. The diamagnetic materials are feebly repelled by the magnet. Paramagnetic materials are feebly attracted by a magnet, whereas ferromagnetic materials are strongly attracted by the magnetic material. Some examples of diamagnetic materials are like copper, zinc, bismuth, graphite, diamond, water, air, etc. And some examples of paramagnetic materials are wood, aluminium, platinum, copper, chloride, sodium, manganese, etc. And the examples of ferromagnetic materials are iron, nickel, cobalt, alnico, steel, etc. So these are the various applications of these magnetic materials. So that's all. Thank you so much.